It's always about a number, that's with any type of traffic.
Greetings, y'all. Welcome to another tutoring session with Graduation Party. I'm Professor Grady, aka Bishop Grady. We are going to get into some major physics soon. We're going to take this tutorial though to go over some basic principles of basically like the foundation of physics, you know what I mean, as far as the language and communication that goes on within physics. So you'll be able to understand when we get into, you know, forces and projectile motion, etc., etc. Now, by the time you get to this point, you should have a thorough understanding of certain parts of mathematics, including calculus, including algebra, definitely, you know, arithmetic, obviously, and probably even some linear algebra. Mainly just the basic principle of the fact that the more unknowns you have within an equation, that's how many equations you need in order to solve that system of equations. But in general, we're gonna start off with something that's very rudimentary, and that is dimensional analysis. Now, what we need to understand is that I think, you know, we have systems of measurement in society, you know, that actually goes for measuring like the length of something. You know, we are all familiar with height measurements, weight measurements. You know, your height can be in meters or feet. You know, your weight can be in kilograms or pounds. You know, and there are certain units, and these are considered units. You know, so if someone weighs 25 kilograms, the kilogram itself is considered a unit of measurement. You know, obviously it's different than somebody weighs 25 pounds, and that's the unit for it as well. But these are both units of weight. You know, or we'll even say mass. Mass and weight are the same thing. We'll differentiate. You'll be more familiar with the difference between the two later, but essentially, your mass stays the same no matter what the gravity is, no matter what planet you're on, whereas your weight is determined by how much gravity is taking a hold on you. Your weight is different in water than it is when you're outside on land. However, your mass stays the same. So you have mass as a dimension. It's considered a dimension. Another dimension, how I mentioned, you know, height. You know, somebody can be 6 feet 7 inches or 6 feet 7 inches tall. And you know, I think Michael Jordan was like 6 feet 7. Actually, all my favorite shooting guards were 6'8". So you know, but I think Mike might have been 6'6". But if you're 6'7", you're solid. I'm trying to think of somebody off top who's 6'7". Who's great, but can't do it right now because I'm not in sports mode. I'm in physics mode. But you have that as a height. A height is nothing but a length. You know, so a length counts as a dimension. If you say something is 25 miles away, you know, and you know, let me spell these out for everyone. Just so you know for sure what these symbols mean. So that's 6 feet 7 inches. Nevertheless though, these are dimensions. This is a length dimension. When we're talking about height or distance, it's a dimension. It's a length. All right, and then finally you also have time. You know, you have days. You know, there's 7 days in a week, 52 weeks in a year, 10 years in a decade, 10 decades in a century, and 10 centuries in a millennium, and so on and so forth. But within the days, you have 24 hours in a day. You have 60 minutes in an hour, and then you have 60 seconds or 60s in 1 minute, right? These are all units of time. So the main dimensions that you have to worry about are time, mass, length, and the reason why we have to stress this is because it's going to help when you have to do a lot of conversions in physics, a lot of unit conversions, and this serves as a guide to let you know if your measurements are adding up, if your equations are making sense, are logical. So I apologize about this T. Jesus Christ. Alright, well, there goes that. If we actually get into a more different types of measurements. For example, speed. You'll see it uses a combination of dimensions. So if you talk about, everybody knows that you can measure how fast something is going by miles per hour or kilometers per hour. So if you have something going, I'll keep using 25. You have 25 miles per hour, typical speed limit in the United States. This is a shorthand version of it, but this is actually 25 miles per hour. That's why you should be sounding your arithmetic as well, because we're going to use this. This is actually really 25 miles for every 1 hour of driving or traveling, but it's typically used with driving and speed limits with driving, but it can be used with anything. But as you see, the dimensions that are being used there are length over time. Therefore, I know if I wanted to take this amount, and multiply it by a quantity that will result in what is a length, then I know that I have to multiply this by a time. And this goes back into arithmetic, where you're dealing with the multiplication of fractions. Length over time times time multiplied by time will result in a length. Will it not? So if I say that I am going 25 miles per hour for 5 hours, then I know that, well, if I multiply these out here and I multiply this number, so 25 times 5 is 125, and miles per hour times hours leaves you with miles. So if I drive for 25 miles an hour and I do it for 5 hours, I will have traveled 125 miles. I will have traveled for 125 miles, and you can apply that principle to anything in physics, anything in nature. If I make 3 cakes every week, I want to create 3 cakes for every week of my life, or every week of the year, right? And I know that there are 52 weeks in a year. Well, you see, if you apply basic arithmetic and actually cancel out these fractions that are the same, you see you will be left with cakes per year. And that makes sense, because then you only have, it tells you exactly how many cakes you will be able to make within a year, and that's valuable. But even if you didn't know what it was going to, and somebody or something told you to multiply these together, this is the answer that you would get, and would let you know, oh, so this is what I'm looking for. So it might sound like it's a little weird to catch on to, but this principle that's going to be used in physics and science really can be applied to anything. So, and while cakes isn't really a dimension, and it's an object, you know, it's not a length, it's not a time, it's not a distance, but it is an amount. Obviously, you are able to cancel out certain amounts as well, and only end up with a number and a magnitude. Maybe that's not so obvious. However, that's a bridge that you'll cross if a problem should ever come up. But as long as you are abiding by these principles of being able to cancel out dimensions, then you know that you'll have the right answer as long as you're sticking to the principles. So that is dimensional analysis in a wrap. Maybe I should give one more example, just in case it's not clear, before we get on into things like position and speed and acceleration. But if we have, I'll say, if somebody has, for every, they have 3 turns. They turn around 3 times per minute, right? You know, somebody's really heavy set, you know, they're taking their time, and you know, they have to turn around 3 times per minute. 3 turns per minute. That is 3 turns per minute, which is basically this is not a dimension, so we'll say n for a non-dimension, right? You know, L is length. Yeah, length or distance, length is fine. T is time, M is mass. So here we have a non-dimension over time. Now if I wanted to say, well, if I just take this and I'm like, well, I want to multiply this by, let's say, and then for every 40 minutes, you actually lose you actually lose a half a kilogram, right? So you would say for every you lose 1 kilogram per hour, right? So you have 1. No, I said 0.5, right? A half a kilogram per hour, right? You can write it as 0.5, or you can write it as 1/2, but it's up to you. 0.5 kilograms per hour. We don't even know what this really is, but we do know, or you may not. If you do know, you know what I'm saying? Let the rest of the class listen, right? We do know though that this is a mass over a time. So if we were to multiply this against each other, right? So you have a non-dimension over a time. How would we get to a point where there's something that we can use? Well, you could get what if we just want to cancel out the time? Let's cancel out the time and see what it does. If we were to flip this, right? You would have T over M, and that would allow you to have a time, to be able to cancel out time, pardon me. So if you do this, you end up with a non-dimension over a mass. What the hell is that going to give me? Like, what does that do? Well, in this case, in using these terms, you would have a number of turns per kilogram lost. That actually does tell us something. This actually tells me I can determine how much weight you'll lose if you're making turns. You know what I'm saying? And you can actually, like, per turn or per kilogram. When you can flip it out, you have it to kilograms per turn. How many kilograms will you lose per turn? But let's just play with the numbers and see what we get. So if we got 3 turns per minute times, well, we had 0.5 kilograms per hour, which is the same as 1 kilogram for every 2 hours, right? Instead, you could use 0.5, or you could use a half. So let's just flip that around. For every 2 hours, you lose 1 kilogram. But these aren't the same terms, though. These are not the same units. You have minutes here, you have hours here. However, these are both times. So the fact that they are both times, that means they can be converted. Just keep that word in mind, conversion, as I've said throughout this lesson. So it's an important word, but it basically describes what you'll end up doing without even thinking about it. But you know that you need to have these terms the same, like in arithmetic, before you can actually multiply these fractions. So what you do, you convert hours to minutes, or you could convert minute to hours. But in this case, since a minute is smaller than an hour, we'll deal with fewer decimals if we choose to put this into minutes. And sometimes a lot of times that makes mathematics easier, mathematical operations easier. You know, I don't have to do too much multiplication, or I can do the multiplication in my head, and you probably can too. It simplifies the problem. But how do we do this conversion? 2 hours to one kilogram. Well, we do know how many minutes are in an hour. As we said earlier, 60 minutes in 1 hour. So that means that if we want this to be just in minutes, we have to get rid of the hours. So we know there's 60 minutes in 1 hour. Now, because there's 60 minutes in 1 hour, this is the same as 1. So it doesn't change the problem. You are literally multiplying this by 1. And let me write this out somewhere else so I don't want to confuse anyone. 1 hour equals 1. Just the number 1. That is it. Minute is a T property. Dimension, pardon me. Hour is also a T dimension. So you end up with a non-dimension. 1 T over T. 1 non-dimension. It's just the number 1. Now, I don't want to confuse you too much, but I say that to say that this is perfectly legal because you're multiplying by 1, right? So it's legal mathematically. And this will also give us our answer. So if we're able to cancel out the minutes, able to cancel out the hours, we are left with terms and kilograms. So, on the bottom, we have 3, which is also 3 over 1. So, you know, the denominator here is 1. 1 times 1 times 1, so we got 1 kilogram on the bottom. And on the top, we have 3 times 2 times 60. 3 times 2 is 6. 6 times 60 is 360. So this actually communicates to us that for every 360 turns that you take, assuming that you are constantly turning 3 times per minute, you will lose 1 kilogram. So obviously, I just pulled this problem, you know, out of my head. Like, I just created this on the spot. However, that's how powerful dimensional analysis and the conversion of units in physics is. We created a problem out of thin air, but it still communicated something to us. So it's hopefully not too hard of something to grasp, but trust, after the second tutorial, third tutorial, you start doing problems, this will be second nature, alright? So again, peace y'all, appreciate y'all tuning in. Make sure you hit that subscribe button to it at the bottom for more. We're about to get into some real heavier physics. I'm gonna make all of y'all scientists by the end of this. Peace.